Hi people. Guess what we're talking about today? More value theorems. That's right. We know IVT, we know EVT, but that's not enough. We need MVT, the mean value theorem, and Rolle's theorem, but they're very much the same thing. So the conditions for MVT are that our function is continuous and differentiable on an interval, and the way that we define continuity and differentiability is a little different, so that's why it's closed and then open, but whatever. Just needs to be continuous and differentiable. That means that there's one number c, which is an x value, one number c such that, and there's a couple ways we're going to say this. The main way that you will see this theorem come up is that it means that f prime of c is equal to f of b minus f of a over b minus a. All right, and you should recognize this as the derivative and the average rate of change, or the secant. All right, so another way of saying this is that the slope of our tangent is equal to the slope of our secant. Okay, or another way of saying this is that my instantaneous rate of change is equal to my average rate of change. So remember IROC and AROC, instantaneous, or the derivative, or the tangent, is equal to the average, which is slope, or secant. Okay, so that's the main idea behind the mean value theorem. So you can kind of think about it as like the average. So the average rate of change is equal to the instantaneous. All right, let's keep going. Okay, now specifically, if f of a and f of b are equal, okay, that is Rolle's theorem. So real quick, let's just look at what this means graphically. So say I had some function, yeah, I don't know what. Let's say it looks like this. Okay, what the mean value theorem tells me is that if I connect my endpoints and I draw a secant line, let's draw a secant. Okay, so this is my secant line. Goes through these two endpoints. Mean value theorem guarantees that there's at least one value where the tangent has the same slope. So it looks like maybe about here I would have the same slope. And actually it looks like over here I would also have the same slope. Okay, but MVT guarantees that it'll happen at least once. Okay, for any closed interval where I'm continuous, it'll happen. Okay, now if f of a and f of b are equal, that would probably look something like a parabola. Okay, and so same thing. If I draw a secant through my two endpoints, that just means that there's a point where it'll have the same slope. Okay, so Rolle's theorem is just a specific case of mean value theorem. I think the only reason why we learn about it is because Rolle's theorem came first. But basically, if I'm continuous and differentiable and f of a equals f of b, then there's one number c such that basically f prime of c equals 0. Okay, because if, again, I'll draw my picture, if I have a secant line going through my two endpoints, hey, and the endpoints are the same, that means that I have a flat horizontal line here, meaning that it has a slope of 0, meaning that any derivative will have the same slope of 0. Okay, so that means that f prime of c will be 0. It means that I'm guaranteed a horizontal tangent line, okay, meaning I have a slope of 0. And another way of thinking about this, which I think is pretty cool, is if f prime of c equals 0, that means that there exists a critical number. So that means that f of c is a critical point. Okay, so my graph is turning here, so it just means I have a critical number. Or you could just say c is a critical point, whatever. Okay, let's keep going. Let's actually go through an example. So first, I need to show that the conditions of Rolle's theorem are met, and then find the c value that Rolle's theorem guarantees. Well, I'm given a polynomial, so make sure when you're using this that it's actually a polynomial, because you can't use this unless it is. But I know that I'm continuous and I'm differentiable because I'm given a polynomial. Okay, you can only use this justification if you're given a polynomial. Okay, polynomials are continuous and differentiable everywhere by definition, but you cannot use this, for instance, square root, not a polynomial. 1 over x, not a polynomial. Okay, you can't use it for these, so don't use it for something that's not a polynomial. But if it is, you could just say this and that's enough justification. Okay, First step, I need to find f of a and f of b. So I need to find f of negative 2, f of 3. Plugging these into the original equation, I end up getting 0 and 0. You can check my math. So basically, because f of negative 2 equals f of 3, Rolle's theorem applies. Okay, so I went through the three conditions, continuous and differentiable, check, check. F of a equals f of b, check, so Rolle's theorem applies. Right, so that tells me that the derivative, so let's find the derivative real quick, which is 2x minus 1. That tells me that the derivative has to be equal to 0. Okay, that's what Rolle's theorem says, it's equal to 0. Let's find the value. So x equals 1/2, and this is what they were asking me. So this is the c value that Rolle's theorem guarantees. I know I solved for x, but it is an x value, so whether you name it x or c, that's fine. You should probably name it either x or c, though. All right, moving on. Now I have a graph. So again, let's just practice what MVT means visually. So I'm given this function, and on the graph, I want to show that I know what MVT is trying to find. So first, let's connect the endpoints. Okay, so here's my secant, and I know because of MVT that somewhere here, about here probably, my tangent will have the same slope as my secant. Okay, so this is what MVT is telling me. Part B asks me to show that MVT applies, and then find the C that the theorem guarantees. Okay, so real quick, let's just talk about where I have issues on this function. I have an issue with 0. Okay, so I know that f is not continuous at 0, or I could say non-existent. Let's go with that. It doesn't exist at x equals 0, but 0 is outside of my interval. Okay, so it's continuous on my given interval. Right, so that's what I'm saying here. Now let's consider the derivative real quick. All right, let's just take a look at the derivative. So f prime of x is going to be positive 5 over x squared. Okay, so again, this does not exist at 0. It doesn't exist at 0. So I know that f of x is not differentiable at x equals 0. But that's the only place that this is going to have issues. So, but I know that it's differentiable on the given interval. Right, so there's my justification. Okay, it's not continuous at 0, but it is continuous on the rest of the interval. It's continuous everywhere but 0. It's also not differentiable at 0, but it's differentiable everywhere else. So because 0 is not on my interval, it's fine. Okay, so there's my justification. All right, now let's find f of a and f of b. So I need to find f of 1 and f of 5. Okay, so f of 1 in this case is negative 2, f of 5 is 2. Okay, now remember what mean value theorem says. It says that the secant is equal to the derivative, so we need to find our secant value. Okay, so that's f of b minus f of a over b minus a. Okay, so that in this case is 2 minus negative 2 over 5 minus 1. All right, and so this, when I simplify it, will give me 1. All right, and so this is my average rate of change, and this is equal to my instantaneous rate of change, which is 5 over x squared. I already found that. So I'm setting my average rate of change equal to my derivative, and I just need to solve for x. So this one's pretty easy. Just multiply x squared over. So x squared equals 5, so x is plus or minus the square root of 5. Okay, now just like with IVT, the negative square root of 5 is not in my interval, so I don't care about that. So I'm only caring about x equals the positive square root of 5. All right, so that's my value of c that the theorem applies. All right, let's keep going. Last question, very reasonable, very realistic situation. I'm driving a car and I'm passing a policeman. 4 minutes later, I pass another one. Okay, both times I pass him, I'm at 50 miles per hour. Speed limit 60. I don't know why I was driving so slow. The distance between the two is 5 miles. All right. I get a speeding ticket for driving 75 miles per hour. How can he prove that you were speeding? Well, let's just think about average rate of change, right? So that's your speed. So let's kind of think about it like 2 points. Okay, when I pass my first police car, okay, I'm just thinking about it in terms of time and distance. So let's say that I'm at time 0 and distance 0 when I pass my first police car. Okay, time 0, distance 0. I'm starting over. Okay. When I pass my second police car, how much time's passed? They said that it was 4 minutes. Yeah, so it says that 4 minutes has passed between the two. So I want to think about this in terms of hours though. So 4 out of 60. Okay, so that's how many hours have passed. That's my time. And the distance is 5 miles. Okay, so I went from 0 to 1/15 of an hour, 0 to 5. Okay, now let's find my average rate of change. Okay, so average rate of change, it's going to be distance over time. So 5 minus 0, and then 4/60 minus 0 gives me 5 over 1/15, which is 75 miles per hour. Okay, so if you just calculate the average rate of change between the two police cars, the average rate of change is 75 miles per hour. Now, that doesn't mean that he drove 75 miles per hour the entire time. He definitely didn't. But overall, that's the speed that he was traveling at. Okay, so for part B, it says that you argue and then he writes you 2 tickets for 65 miles per hour, which is weird. Okay, so now let's use the two value theorems here that we know. Okay, so MVT stated that we hit 75 miles per hour at least once. Okay, so remember, it's saying that your average rate of change has to equal your instantaneous rate of change. That's what MVT says. So if your average rate of change was 75, it means that you drove 75 miles per hour at least once. Okay, so for at least one instance in time, you drove 75 miles per hour. Okay, now if you passed the first cop car at 50 miles per hour, and I know that at least one time you were at 75 miles per hour, and then you passed your second cop car at 50 miles per hour, that means that because of IVT, I had to hit 65 miles per hour at least twice. Yeah, I don't know how many times I hit it, but at least twice. So I can say that IVT states that you hit 65 miles per hour at least twice, resulting in 2 speeding tickets. So if this ever happens to you, that sucks, but not much you can do about that. All right, that's it. Later.
Press F10. Where's F10? Oh.
Get it together.
Is it recording?
Here.
Is it recording? Wait, how can you tell it's recording?
We can F in.
You better not. No.